Good morning, students. Yesterday we have started the chemical reactions of aldehyde and ketones, and firstly we have done nucleophilic addition reaction. So aldehyde ketones was maximum nucleophilic addition reaction due to presence of double bond between carbon and oxygen. Some electromagnetic effect takes place, and due to the presence of electromagnetic effect and due to this electronegativity difference between carbon and oxygen, some deficiency of electron takes place inside carbon, and that is why nucleophile can attack to the carbon, and nucleophilic addition takes place and the double bond will be converted to single bond. Now I want to give one example. Suppose you have to convert ethanol to lactic acid. Ethanol formula you know, CH3CH2OH, and lactic acid is like this. It contains one OH, one COOH, and one hydrogen is present. This formula is called lactic acid. And this type of carbon, which contain 4 different groups surrounding the carbon, here it is OH, AH, COH, CH3, all are different. This type of carbons are called chiral carbon. So in stereochemistry you will get this. This is called chiral carbon because all the groups joined with carbons are different. Now if you want to convert ethanol to that lactic acid, how do you convert? So here you can apply the nucleophilic addition reaction. I will show you. First time you do oxidation of the alcohol by applying some weak oxidizing agent like PCC. When alcohol undergo oxidation, it produces aldehyde, CH3CHO, and CH3CHO, you know, it is like this. After getting this, you apply HCN, which I have done in last class. As you know, H is plus, Cn is minus. Cn will be attacked to it, oxygen will be transferred to it, double bond is transferred to oxygen. That means you will get CH3, here Cn will be joined, here hydrogen, double bond is converted to single bond, oxygen combined with hydrogen, it produces OH. So now the difference between lactic acid and this one is, here it contains Cn, here it contains COH, others are same. So what you have to do? Just to do hydrolysis. When you do hydrolysis, cyanide is converted to COOH group. Ultimately, the ethanol you convert to lactic acid. So these are the application of this reaction. In conversions, you can apply this type of reaction to convert one compound to another compound. Okay, now we'll do. Again, we'll start the reactions of aldehyde and ketones. Again, nucleophilic addition reaction followed by elimination of water molecule. This is another type of reaction which is shown by aldehyde and ketones. Yesterday we have done only nucleophilic addition reaction. Now this is also nucleophilic addition reaction, but here elimination of water molecule takes place. So first time I will show you about the mechanism of the reaction, how the reaction takes place. This is one of your carbonyl compound. It may be aldehyde or it may be ketone. If you put hydrogen, then it goes to aldehyde. If you put both side carbon, then it goes to ketone. Normally this type of reaction, nucleophilic addition reaction followed by elimination of water molecule, this type of reaction shown by aldehyde and ketone with ammonia derivatives. What is the formula of ammonia? NH3. So this is your ammonia. When the hydrogen of one hydrogen of ammonia is replaced by one group, suppose the hydrogen is replaced by a Z, then this is called one example of ammonia derivative. There are so many examples of ammonia derivatives, I will give you later. For example, the hydrogen is replaced by OH, then it goes to NH2OH. This is called one example of ammonia derivatives. Suppose the hydrogen is replaced by one NH2 group, then it goes to NH2NH2. This is one example of ammonia derivative. So when the hydrogen of ammonia is replaced by some another group, then that type of compounds are called ammonia derivatives, and this type of reaction shown by aldehyde and ketone only with ammonia derivatives. So now I will show you about the reaction. Suppose this is your ammonia derivative NH2Z. The reaction takes place like this. This NH2, you can write like this way also, NH2. The hydrogen of NH2 group combine with the oxygen and it removes water molecule from it, and other part will join. Like this way you have to write the mechanism. It becomes NZ and it removes water molecule. Normally in addition reaction double bond is converted to single, but here double bond is remain here because due to elimination of water molecule. So that's why double bond remain as double bond. So now I'll give you some example. The mechanism is like this. Like this way you have to write the reactions. Number 1, reaction with hydroxylamine. Hydroxylamine. This is one example of ammonia derivative and its formula is NH2OH. One hydrogen is replaced by OH group. So this is your aldehyde or ketone carbonyl compound. When it combines with this hydroxylamine NH2OH, the hydrogen combined with oxygen produce water, and the remaining part will combine like this, double bond N, OH, and side product will be water. This type of compounds which contain C double bond N OH, this type of compounds are called oxime. So when aldehyde ketone reacts with hydroxylamine, it produces oxime. Number 2, reaction with hydrazine. Hydrazine is another example of ammonia derivatives. Its formula is NH2NH2. I mean the hydrogen of ammonia is replaced by NH2 group. Then the compound is called hydrazine. So when aldehyde ketone reacts with hydrazine, NH2NH2, here also hydrogen combines with oxygen to produce water, and the remaining part will combine to form NH2 plus water. This type of compounds are called hydrazone. Hydrazone means those compounds which contain C double bond N NH2. That type of compounds are called hydrazone. So hydrazine is one example of ammonia derivative, and when aldehyde ketone, I mean carbonyl compound, reacts with hydrazine, it will convert it to hydrazone. Now number 3, reaction with phenyl hydrazine. This is another ammonia derivative, phenyl hydrazine. This is your aldehyde or ketone. Phenyl hydrazine means this one, NH2, NH. This is the benzene ring which is called phenyl hydrazine. So when the reaction takes place, water is removed, other part you just combine and NH like this, side product will be water, and this is called phenyl hydrazone. It's like hydrazine, only the difference is in hydrazine NH2NH2 and in phenyl hydrazone one hydrogen is replaced by your phenyl group benzene ring. That's why it is called phenyl hydrazine, and the product is called phenyl hydrazone.